there, it's time for lesson 3.3, and this is all about proportions, and it's still all linked together with our ratios and our rates and our slopes and all that good stuff. It's pretty cool how everything ties in. I'm hoping that's what you'll see today. So what is a proportion? It is an equation. Just when you thought we were done with those, they're never going to go away. It's an equation that states that two ratios are equivalent. So remember that ratio can be written as a fraction, comparison of two numbers. It's basically taking two fractions and putting an equal sign between them, saying that they are equal. So two quantities that form a proportion, meaning they equal one another, are said to have a proportional relationship. They equal one another. So when I say, do they have a proportional relationship, I'm asking you, are they equivalent? Are they equal to one another? For example, 1/2 and 2/4, they have a proportional relationship because they are equivalent. All right, so basically what I want you to be able to do first today, I want to give you two ratios, and you need to be able to tell me if they do form a proportion. So you need to be able to tell me if they're equivalent. And there's actually 3 different ways to figure it out. You can kind of pick which one is your favorite. I'm not going to force you to use one way or the other. I'm guessing which one will be your favorite. I'm kind of certain about it, but you still have the option of all 3. So here is option number 1. And I'm just using 1/2 = 2/4 because you know that that one's true, right? So I'm taking one that you already know and showing you how these 3 ways work with one that you already know the answer to. So we already know that they are equivalent, right? They do form a proportional relationship. So when it says compare the ratios in simplest form. So option number 1, simplify them. So 1/2 is already in simplest form. If you simplify 2/4, that simplifies to 1/2, which is equal to 1/2. So that's one way to tell. Another way is that you can calculate the unit rate. And remember, with the unit rate, you just divide. You take the top divided by bottom, right? So if you take 1 divided by 2, you get 0.5, 5/10. If you take 2 divided by 4, you get 5/10. Both of them are equivalent. So again, step 1, you can see if they simplify to the same thing, so simplify each ratio. Step 2, you can just calculate the unit rate for each and divide the top by the bottom and see if you get the same decimal. If you do get the same, that means that yes, they do form a proportion. Or the last thing, and this one I think is pretty cool, you can use something called the cross products property, or I like to call it CPP. Can you see why I like that one the best? So the cross products property basically says that if you cross multiply, you'll get the same result. And here's what I mean. If you take 2 times 2, so across from one another, you get 4. And if you take 1 times 4, you get 4. And 4 equals 4. That actually works for every single pair of ratios that are equivalent. You just cross multiply, and if the cross products are the same, that means that they form a proportional relationship. All right, so let's try a few, and I'm going to actually have you use all 3 methods on the notes. When it's homework time, you don't have to use every single method for each problem that you solve, but I do want you to know how to use all 3 of them so you can have the option of picking what's easiest. All right, so we have 4/10, 10/25. The question is, do the ratios form a proportion? Meaning, are those ratios equivalent to one another? So method number 1 is to compare the ratios in simplest form. So if you take 4/10 and we simplify that, the GCF of that would be 2, right? And 2 goes into 4 twice, 2 goes into 10 5 times. When you simplify 10/25, the GCF is 5. 5 goes into 10 twice, 5 goes into 25 5 times. Because they're the same, the answer is yes. Option number 2, I said to compare the unit rate, right? So for the first fraction, 4/10, you can take 4 divided by 10, and you get 4/10, which makes sense because it's 4/10, right? And then we can take 10 divided by 25, and if you have your calculator handy and you want to take 10 divided by 25, you end up, yes, getting 4/10. It's a yes. It's always going to be yes once it's a yes for one method. different methods won't give you a different answer unless you do it wrong. All right, so number 3, we can use cross products to see. So in this one, here are our ratios. We want to know, are these the same? So if we cross multiply, 4 times 25 is 100. 10 times 10 is 100. 100 equals 100. So no matter which way you look at it, the answer's yes. So if you're really good at simplifying fractions, you might want to do that. If you always have your calculator handy, you might just want to divide and change it into unit rates. If you just think that the cross products property is so cool because it works every time, use that if it's numbers that are easy to multiply. All right, let's try the next one. I have 6/8 and 3/4. We're going to do this all 3 ways. So way number 1, we're going to simplify 6/8. All right, 2 goes into 6 3 times, 2 goes into 8 4 times, and the other fraction that we have is 3/4. So it's a yes. 3/4 does equal 3/4. The second way, I could take 6 divided by 8 and 3 divided by 4 and make sure I get the same thing. When you take 6 divided by 8, enter, you end up getting 0.75. And if you take 3 divided by 4, you get 0.75. It's still a yes. The third method, we could set this up and cross multiply them. 6 times 4 is 24, and 3 times 8 is 24. 24 does equal 24, so we know that it's a yes. All right, we're going to try one more of these. And again, all 3 methods. I know it's kind of tough to have to do all 3 right now, but again, you won't have to do that in your homework assignment. For now, I just want to make sure that you're familiar with all 3 because sometimes one is easier to use than the other. You want to know how to do all of them. All right, so step 1, we're supposed to compare them in simplest form. Well, 5/7 is already in simplest form, and 2/3 is already in simplest form, and those don't equal each other. So right now, this is a no. Those do not form a proportion. They don't have a proportional relationship. They're not equivalent. See, I can even say the same thing 3 different ways. So let's see how it would look at the other ways as well. The unit rate would mean take 5 divided by 7 and take 2 divided by 3. So when you take 5 divided by 7, you end up getting this decimal right here, 0.714, and I'll just stop there. And when you take 2 divided by 3, I bet you a lot of you already know this one, we get that 0.6 repeating. Do you see how those are not the same? That means this is still a no. All right, for number 3, we can use the cross products property. All right, so if you take 5 times 3, they're across from each other, you get 15. And if you take 7 times 2, you get 14. 14 does not equal 15. So no matter which method you use, it's a no for every single one. You just have to pick which one you like the best. All right, so that's part 1 of today. Part 2, I want you to be able to take a math story and determine if there's a proportional relationship going on. So yes, story time. Determining proportional relationships from verbal descriptions. What you need to be able to do is take a verbal description and set up a proportion to represent the situation by matching up the variables, and then you can choose any one of the 3 methods to determine if they are proportional or not. So take a look. It says, try, write a proportion to represent the situation, then determine if the relationship is proportional. So here's situation number 1. Let me zoom in a little bit. You read the first 20 pages of your book in 25 minutes. You read 36 pages in 45 minutes. Is the number of pages read proportional to your time? Okay, now with these, there are actually several ways you can set them up. I'm not going to make you set them up a million different ways. I think I'm just going to focus on one way. But no, there are other ways, and we will explore them in class in our next set of notes. But for now, just focus on the one way. And we'll just look at these as rates. It said you read the first 20 pages of your book in 25 minutes. So if we're looking at this as a rate, that would be 20 pages per 25 minutes. Right? So that's our rate, 20 pages per 25 minutes. And now I want to know, is that the same as when I read 36 pages in 45 minutes? So the 36 goes with the pages. That needs to go on top because the other pages are on top. And it's 45 minutes. The minutes need to go on the bottom across from the other minutes. So when you're setting this up, in the beginning when I said matching up the variables, pages should both be on top, minutes should both be on bottom because we want pages per minute. Okay, so now what I actually have here is I have 20 25ths, and I want to know, is that equivalent to 36 45ths? So pick away. We need to pick away. We can either simplify both of those and see if they come out to be the same thing. We could find the unit rate and take top divided by bottom for both to see if we get the same thing. Or we could use our cross products property and see if we get the same thing. I'm going to use that just because it's kind of a new one. So if you take 20 and you multiply it by 45, I get 900. And if you take 25 times 36, you get 900. So the answer to the question, is the relationship proportional? The answer is yes. So we wrote our proportion to represent the situation, and we determined that, yep, you're reading at the same rate in both of those situations. All right, last one for today. It says you swim your first 4 laps in 2.4 minutes, and you complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So I'm basically asking you, are these the same rate? Are these proportional to each other? So step 1, we want to write our proportion out. So the first situation is 4 laps in 2.4 minutes. So 4 laps per 2.4 minutes. That word in means the same exact thing. The other situation that we have is you completed 16 laps in 12 minutes. So 16 laps and 12 minutes. So laps are across from laps, minutes are across from minutes. So the proportion I'm actually solving here is 4 over 2.4, and I want to know, is that equivalent to 16 over 12? Okay, so for this one, I think I'll use a different method. I think I'll find the unit rate. Why not? So I'm going to take 4 divided by 2.4 and 16 divided by 12 and see if I get the same thing. So 4 divided by 2.4, that gives me 1.6 repeating, and 16 divided by 12, that gives me 1.3. So right here, there's my proportion. The answer to are they proportional is no. If you wanted to use the cross products property, then 4 times 12 would be 48. And when you take 16 times 2.4, you get 38.4 when you multiply those two. So if you like that property, which I love it, so hopefully you'll love it too, you see that it doesn't work either. So that's not a proportional relationship because they're not equivalent. All right, you are done. See you later.